everybody. Thanks for letting me talk to you while you're eating, captive audience. Do you guys mind if I don't stand at the podium? So I was on the last panel, so spoiler alert, you've seen a little bit about what I'm going to talk about, but Windtalker Innovations is a company that's trying to make software that can transform today's hardware into a new kind of network that solves all the problems of the historic networks. So that's kind of the that's the vision, right? Every device that you have talks to every other device. So we're going to talk about some specifics here and why we think we can do that, why we're so audacious to think that's possible. And so we're specifically talking about how Windtalker Innovations is trying to help solve internet scarcity. First thing we're going to talk about is the automation of networks and an off-grid component of this and what we mean by that, and why we have a lot of expertise in off-grid networks from our experience as a company with tactical networks for the military and other sort of first responder solutions. We also are going to talk about the benefits of taking those lessons that we learned from military networks and putting those into the ISP networks to solve the problems that we're talking about. We'll talk about how this is not just a theory, it really is something that we've productized and it's available right now. Wink, wink, if you're an OEM or a partner. And we'll talk about the products that we have today and how we're going to take us to internet independence is what we're talking about. So this is, you own your internet and you decide how much you want to interact with the outside world. So this is me. I am an Air Force veteran. I spent 14 years as a tactical air control party member, or a JTAC. I was a terminal attack controller for the Air Force. If you know what that is, cool. Basically, I worked with the Army, and the first thing that I needed to do anytime I was out with the Army was make sure that I was on the network. So I carried man-portable radios to the middle of places, really austere locations in Iraq and Afghanistan, and set up our networks while we were in the field with the Army, did overwatch over missions, et cetera. Because if you don't have the ability to communicate with higher echelons, then I can't call aircraft to come in and help us if we need it, right? So the very first thing that the military does, it's actually the second thing. If you look at the Ranger Handbook, okay, first priority of work is security. That seems fairly obvious. Second priority of work is communications. Military networks military units know that the most important thing they can do after securing their own location is connecting to other military units, right? Get your reinforcements set up. So I have a lot of experience in that. I was enlisted in that for 8 years as an officer. I went to other countries and sort of advised them on how to use these different things and tools. But I didn't found Windtalker Innovations. Matt Purdue, Executive Director of the Connecting Alaska Consortium, founded Windtalker Innovations. And Matt here is a retired Air Force veteran, air battle manager. And with this gentleman here, Ryan Luther, our co-founder, they worked together to create Osmosis and our company about 8 years ago. And over the last 5 years, or for that next 5 years, they went through all the different trials trying to figure out how to make this kind of network possible. They patented a lot of stuff, and over the last 2 to 3 years, we've really been honing in that strategy and saying, you know what, we're going to use this to solve the biggest problem we see, which is connectivity for everyone. Until we've solved that, the next things don't matter. So we decided to focus on that, and basically, you see from right here, Matt says, I wanted to take decades of DoD network experience and parlay that into something meaningful for the unserved or underserved. And that's exactly right in a nutshell. So how does that work? How do we take military networks and convert those for civilian or commercial purposes? Well, there's some stuff that's obvious, right? There's the first responders situation. Somebody gets lost in the woods. You need to go find somebody. You don't have communications. Those pieces of equipment, those types of networks, there's pieces of that already exist today that companies are trying to solve, and it's very expensive equipment. It doesn't scale well, and it doesn't actually tie into the residential or commercial infrastructure. But right now we have our CTO, our Chief Technology Officer, the guy that's really the brainchild of all of this, or the author or inventor of the technical code components of this. He was a first responder for fire and rescue, for wildlife fire and rescue. And he knows people today that would be alive if only the radios that were in between us and that during that golden hour of the injury to getting emergency treatment, if only we would have had the radios that were in between those locations able to transmit patient information ahead of schedule and make ready the materials and supplies needed to save that life. He knows people that would be here today because of that. So for him, this is very near and dear. How do we take off-grid and automatic networks and make those as accessible to everybody as we can possibly make them? A less intuitive application is to take an off-grid network and to connect somebody that could potentially be on-grid, right? So if I'm going to bring you fiber, or if I'm going to bring you a wireless ISP connection, you are effectively joining the grid, right? That's the whole thing. And so why would we use off-grid capabilities? That's not an intuitive leap for most companies to get to. But when we look at the way that these networks work, we start to see that all of the problems we are suffering from with resiliency, all the problems we're suffering from ease of use, ease of setup, all of these can be solved once we make a network truly automatic and off-grid. Because the steps that we have to take for those routers and those connection points to look around and see the other places where they can send information, because of when they do that, they automatically solve a lot of our problems. So I'm going to kind of show you how that looks and what that looks like. Before we show this video of how this works, I want to just challenge you to think about this as we watch the video. What if 20% of the data that you need to move was data that could just stay inside of your village? You need to call somebody on the other side of town. You need to relay back to the ranger station that something's happening and they're within line of sight. You have a local hard drive with educational materials or videos on that. What if 20% of the information that you want to consume using your internet device in your house, what if it could be accessed with total absence of internet? No fiber, no Starlink, no nothing. But you've got hard drives, it has content on there that you've approved for your community, and anyone in your village, as long as they have power, they can access that using an osmosis-enabled router. What if that was possible? What if it was 20%? What if it was 50 or 70? We start to reduce the amount of demand that we're putting on those backhaul systems. I'll show you how. So essentially we have this point A and point K. I'm going to provide the voiceover for this because I did not have it in time. Right now what's happening essentially is A knows that it needs to get a message to K, and so it's using it's looking at the nodes around it to figure out if it can establish a path from across town from A to K. And so what it's doing is it's identifying all these paths before it executes the actual transmission of data. And then what we have, and you'll see this in a second, is there is a way for us, we have something called prioritization, message prioritization that's built into this. And we can configure and add to that. But essentially, you could say, I want to use this path because it's cheaper to get to, or because it's shorter or faster. And you can make determinations of what you want to do. And now, like you see here, we see this path lit up. All the nodes have been evaluated, and because of the parameters, all of this is happening automatically. The message goes from A to E to C to F, J, I, and K. And all of that traffic stayed offline, never had to leave. Your village couldn't get stolen because you'd have to be in that path to ever even see that that message existed. Does that make sense? If I'm not standing in between those lines, I don't know that message exists. I can't steal it. Right? So, Why off-grid networks matter. One of the things that came up on the panel at the end, and I think it's important to talk about, is capacity. Okay, you guys, and we also talked about environmental concerns. What lives in the ground matters. What happens when something burns up in the atmosphere matters. Just because we don't know it doesn't cause cancer today, doesn't mean it doesn't cause cancer, right? So wireless, yes, we have wireless transmission signals. Unfortunately, if people are popping that stuff up, everybody's enjoying whatever that's doing to us. We'll stay away from that for a second, okay? But when we start talking about wireless's ability to mitigate things like digging, well, it's obviously very valuable. When we start talking about maintenance and sustainability of a network, if I don't have to dig a trench to replace the fiber line in 40 years, that's valuable. If I can just put things on the side of buildings that are wirelessly grabbing or sending data, that's probably one of the most sustainable options that we have to us. But here's the challenge, here's the rub. This is what you're going to hear from the fiber companies. Your capacity isn't very good on wireless things, right? Fair point. Here's the thing that's cool about off-grid automatic tactical networks. Because we have the ability to send information across any available path, we can also send information across all available paths. So it's not a direct comparison to say the 200 megabit per second shot from the wireless carrier is inferior to the fiber carrier. Because if I have 10 data paths and I have 200 megabits for each one of those data paths, that's 2 gigabits of service. Because I get the aggregated effects of wireless services when I use graph-based networks. Put it this way, our wireless equipment today, commercial industrial wireless equipment today, if you've ever anybody got experience with an in-home wireless mesh device, right, okay? You have the satellite nodes and the base node. You plug the base node into the internet and your satellite nodes connect to the base node, and that's how it works. That's called hub and spoke mesh. With our solution, you plug internet into any one of those nodes and it automatically shares it with the rest of the nodes. Automatic failover because of graph-based nature of our network. That's today. I can put 100, 200, 1,000 nodes in the same mesh. No problem. Backhaul solutions spread out all over that mesh, and they're all going to share with the ones around them that can see that far. Now, I say see that far. We still have issues with, 1 over N and stuff like that. And Wi-Fi 7 and some emerging technologies are solving those. So if you're technical in here and you're going, yeah, but what about this? We're solving the problems that need to be solved. What we have today is a commercial industrial Wi-Fi mesh that is more scalable and more flexible when it comes to your backhaul than any other solution in the world. And right now, that's brought to you by Netgear and WaveSight from England. So, that said, I like to equate it like this. If the interstate is clogged, what does Google Maps do? It takes you off an access road and side roads, and you get to know your city a little better. But if you're like me, you don't remember any of it because you're staring at the map the whole time. I would get, just side note, I'd get destroyed right now if I went in front of my military training instructors and tried to do navigation because I'm so out of practice because of these phones. But it activates the tributary roads, right? Because sometimes a 30-mile-an-hour road is the fastest way to get to your destination when the 70-mile-an-hour road is jammed. When it comes to osmosis, when it comes to these graph-based networks, if we start to establish these other less capable, lower capacity paths, the resiliency and redundancy impacts and the capacity are all improved by this graph-based tactical network. So we decrease the number of cars on the road, we decrease the traffic, that's good for everybody. We just have to figure out how we want to do it. So I mentioned this, we have products from theory to products. This is what we have today. If you wanted to look at it on a map, we have commercial, industrial, indoor, outdoor Wi-Fi. We believe these are the easiest networks to set up. If you want to take a look at the end user experience here, essentially if you were to peel the top off of one of these buildings, you would see somebody just coming in here, setting this network up by plugging it into the wall, and it just works. It automatically joins the network. There's no additional configuration. You set the SSID, you set the password, and you're online. You got 100 of these, turn them on, set the SSID, password, you're online. Oh, incidentally, if you're an ISP, you can throttle and manage every single one of these nodes independently. You want to make it 20 megabit max? Set it in the UI. That's one of the 4 things you can actually change. It's a very, very simple network. And our intention is everything that gets used by in any of our products, you turn it on, you set it up, and it works. And you don't need a degree. You need a high school education or maybe just the ability to read and use a power drill. That's what we're trying to build. So what we were going to do, advance that one more. We believe that we have essentially 30 to 40% of routers are in commercial networks. So by doing commercial industrial Wi-Fi, we start to grab these big little geographic sections of society. If you go one more step forward, you start to see these bubbles pop up around MDUs, these multi-dwelling units, for example. That's a place that's spreading out the network in a big fashion, which is enabling us to start connecting and providing off-grid connectivity between parts. Off-grid connectivity is great, but if you're standing in the same building, it's not going to matter from me to you, right? Hey, right? I don't need off-grid connectivity for that. I need off-grid connectivity where people actually want to talk to each other across some sort of distance. So throughout an MDU, maybe, throughout a warehouse, throughout a shopping center, people are going to need to communicate. They may want to do so off-grid. We're standing up that capability now. But the next thing that we're doing is going to start connecting those different areas and making that capability more valuable. What you're seeing, though, from this, when I say off-grid, if you're an ISP, you need to hear what I'm saying right here. I'm saying 9 nines of availability. Localized, 9 nines. Certain applications, you want communication off-grid. It's like what Emmett was saying, but that's more of a modern solution based on current capabilities, and it's a little expensive. Maybe for some of that off-grid capability, it's accessible, but it is that 9 nines of constantly up. You're never going to have to worry about the emergency broadcast system. As long as you have power to your router, you're going to get that message. That's what we're going to offer to villages or people who use our products. And for ISPs, that's one of their biggest challenges to solve, is resiliency and reliability of service. Right now, just so everybody understands this, if you're curious, we're releasing the technical thing that we need to release this month that's going to allow our first partner to build that off-grid connectivity capabilities. And the very first features that will be done by the end of this year are text, voice, video, and file transfer. We'll be able to send all of those things completely without the internet. And from there, we have places to go, like file storage and stuff that are actually within 2025's reach. Slide. Okay, so now we start to see the bubbles all getting connected together because this is sort of where we're taking the network and our next steps. Can you build that? So you start to see the off-grid capabilities happen. Oh, I've got the clicker. Sorry. So we start to see these off-grid capabilities. One thing that I did here that I wanted to make sure is clear, one of our next steps on our roadmap is to get into fiber equipment. So we want to be in the actual devices that are on the fiber, because everywhere we have devices, osmosis is able to see another path, another way to get your data where it needs to go. So by putting all of this onto fiber as well, you connect these bubbles, these wireless bubbles, with hardwire backups, which could actually become the primary, I suppose, but osmosis is going to use all the different internet sources all the time, so primary and secondary are really just where's the traffic. All right, so this is what I would like to say is not just digital sovereignty, this is digital independence. You know, we got to remember that the original internet at some point was in a room. It was a network that somebody built and they said, hey, this is pretty cool, let's make it bigger. And eventually it took over the world, now it's the internet, okay? I've been explaining our solution this way. And if you're technical at all, you may care about this. If not, I think the analogy works. If you're technical, you're gonna wanna know how, and we can talk about that. So The internet is built on a foundation that was built 30 to 40 years ago. Okay, I mean, the foundation probably goes back further than that, but network.service, the code that is on the basis of our internet, is 7 million lines long. Why is it 7 million lines long? Because for 40 years, we've been adding to it. Well, why have we done that? Because the internet, the business parts of the internet, are all connected to that foundation. Okay, so what we're trying to do here, the reason why the big companies haven't fixed this, is because we're essentially jacking up the house, removing the old foundation, and putting a new foundation under, and then connecting the plumbing and electrical and everything that needs to be connected, and setting the house back down. And that's really hard. And we've learned for over 8 years that this is the task at hand and this is what we're doing. But here's what we've done. We've said, you know what? The tech giants who probably are all messing with this software already, they're not sharing it with anybody. This is trillions of dollars of ideas we're throwing around out here. And I don't want to own them all. Okay? What we want to do is be that licensable firmware and software that all of the manufacturers who are having to deal with the tech giants, all of them come to us and say, we want you to be our network firmware. That's what we want. And what happens from there is we start to build that. Because all the OEMs who are already selling to these places can just put their equipment in there, and if it's osmosis enabled, it's going to communicate with all the other osmosis enabled equipment in the environment. That's how we're going to do internet independence. This enables everything you can imagine. I think at these conferences we talk a lot about teleeducation. We talk a lot about first responders and disaster response and all the reasons why you need reliable networks, why these are life-saving things. I don't want to belabor that point, but I do want to emphasize that this is all possible in ways that nobody even realizes, because we're taking the things that people are building for tactical networks and we're applying them to the civilian networks in ways that other people haven't done. This one's meaningful to us. If you notice, we don't have a table full of equipment that we're currently selling. I'm very sorry about that. My CTO and all of our equipment just got hit by Milton in Lakeland, Florida. And everybody's okay. I'm very happy to report. But we couldn't get the stuff here. So I'm very sorry for that. Incidentally, if there's a hurricane and your community, or I know you guys don't deal with hurricanes. If you guys have a tsunami or some other sort of disaster and you have osmosis networks in your area, not only do you have that off-grid capability and coverage, but we have partners like Lisa at Teltech who has a drone, a tethered drone capability, that if you float that thing above this network with an osmosis node on it, guess what? And it has a Starlink attached to it, every single person in your village is going to have immediate connectivity restored because of the way graph-based networks work, because of the way tactical networks work. So when we talk about disaster response and teleeducation and all these kinds of things, we're trying to make this not only something where you have that robust capability of the edge of the servers in your village, but we're trying to do that in a way that anybody can set up and run and make that just a thing of the past. You know, remember, a computer used to take up a whole room, right? Technology gets smaller and it gets more automatic over time. Our networks are 40 years old. They're due for an update. What I'm talking about is not science fiction. This is absolutely possible. And I'm just hoping to bring that sort of flavor to this conference, because you guys are trying to make real decisions about real products that exist today. I can't solve all of those, but I want to encourage you. If anything I'm saying is resonating with you, tell us, tell me, because I will take that to the equipment manufacturers and say, I heard it directly from the people who want this. This is what they want, and we'll go work to make those things happen. Specifically, if you're interested, Teltech Group. Lisa Hanlon in the back here, they're a dear friend and partner of ours, and we're working directly with them to sell our products and also to take the next major innovative leaps. And we are continuing to find ways to work together in very official capacities to to make this thing a reality. Incidentally, we also have Breath of Life. Our co-founder, Ryan, who you saw in one of the first slides, has created a company designed to build those decentralized applications, that set of functions that you all, for the things that you all want from your networks to work completely off-grid. Breath of Life is our partner who's going to be helping us build those initial functions. But Emmett talked about the applications that everybody uses. What we're doing is working towards a way to get more and more of those applications, and then eventually we want it to be totally seamless. We want the major apps that you all know and love to work across our networks, and we have a roadmap to get there. Okay, that's my presentation. If you want any more information, there's a QR code for my website, but I'm happy to answer questions. Anybody have any questions? Yeah, please. Here, I'll give you this.
Thanks. So you're talking about a mesh network that's not necessarily brand new. How does there's obvious ways that your product, your developing product, would differentiate from something like Meshtastic. What do you use as your underlying, your codecs? Using LoRa, or what are you using there? Can you say?
Most of that stuff we've built is proprietary. It's replacements for the things that most companies are using. A lot of stuff's built on Batman. Are you familiar with the Batman mesh protocol? So that sort of has a natural upper limit of 256 users on the network, for example. There were large portions of problems that things like those open source had, which is why we had to redesign it so that we could do tens of thousands, hundreds of thousands, millions of nodes. Happy to share any of that. If you're really technical and you want to talk to my CTO, I'd be happy to set up a meeting.
Okay, thanks.
Yeah, Sean, can we pass the microphone back?
Can you talk about security?
Yes, security, excellent. So a couple of things on security right now. We run, so our networks are, yes, we do the forward-leaning mesh edge network stuff. I hesitate to even say mesh because it's so much different than everybody else's mesh in the way that it's built, that I've been told, like, hey, it really conjures a lot of negative things for some people that we don't do. So, but when we talk about security, we are backwards compatible. It's important for our network to work with all the other networks until such a time when everybody's graph-based. So we currently deploy WPA3 and other basic Wi-Fi security protocols at the, whatever the most current is. We try to stay at the very top of that because we know how important it is. I mentioned physical security. This is a really interesting concept to me as a military guy who, when I think of information security, because we had to do training on that constantly in the Air Force, you have an element of that is physical security. You'd be amazed how many hackers are getting into systems that are impenetrable because they have access to the facility where they can get and plug something in and run their nefarious tasks that way. So also with the cloud, like we've talked about at length today, your message goes out of your village and who knows where and back to your village because you're using cloud-based services. So when you say data transmission stays at the edge and only the messages that need the internet go to the internet, well, those messages are really hard to intercept, much less break into. So from a security perspective, we offer an element of security that pretty much nobody else is offering unless you've got a very well-designed network. The last thing I'll say is we just did we finished earlier this year a project with Air Force Global Strike. And one of the things we did with them is we put osmosis into military radios that are being used in surveillance planes. And just to show that it works. We're not deployed currently on military networks anywhere, if anybody cares. But we wanted to talk about it working. We wanted to look at our stretch capabilities. One of the things we needed to do was figure out what is the roadmap to get to a top secret capable mesh network. And so we have roadmaps with all of the steps and partners lined up to get to that level of security if we so choose. We're not doing that right this second, but we've got, so to summarize again, we have the industry-leading Wi-Fi security standards. We have something new in the fact that we can do physical security, keeping your data where, at the edge. And finally, we have roadmaps to get to the top tiers of security with the NSA. Yes?
Yeah, I get another question kind of about security. If somebody is using osmosis in a village, but they are connecting to the internet with it, and you've used the C word a few times, getting onto the cloud. If it's encrypted, does that mean that by the time it gets to Utah, it's encrypted and it's, you know, essentially kind of encapsulated there? And you might want to explain what I'm talking about if people don't know.
Well, I'll be honest, man. You're getting real close to the edge of my knowledge on the tech side. Just to be clear, so I may show my ignorance a little here, but I'm going to give you the answer that I know from my CTO to be true, and then we'll get you more information. So osmosis has been designed to where each message can carry its own security. Okay, so you can actually transport the message with its own security that's sort of encapsulating it, like you're saying, and then the people on the other end need to be able to unbox that. We actually demonstrated that for the Army in a program called X-Tech about 1.5 years ago, and what we showed is that say you had a device that was in the middle of multiple devices and you needed to get your message across a device that from a security perspective shouldn't be receiving that message. We have a way to do that in a way where it totally passes through, and the device that's being used as the relay has no idea that message exists. And like I said, it can have its own security transported with it. Our long-term vision from a security perspective, just so everybody kind of see, if you love the technical side and you want to really nerd out with this with my CTO who loves this stuff, I would say long-term, we want to be able to split a message into multiple parts, transmit it across different paths, and then reassemble it on the end. That has a lot to do with some pretty advanced timing work. When we start talking about decentralization across a mesh, we'll need atomic clocks to be really at the edge managing the timing on that. But I gather that those now exist in a very small form factor and can be part of radios within the next couple of years. So it's a very cool time for us in terms of security, because right now, you're up against supercomputers and states who know that I don't need a big military to affect the powerhouses of the world. I need a good team of hackers. And so that's what they're doing. And it's great, but like we have to transform the way that we think of security entirely, because right now there's 7 million lines of code, and guess what? You can't cover all the places where people can get in. It's too complicated, it's too complex. We have to rewrite that. By the way, that 7 million lines network.service, I don't know all the details, but we've rewritten about 1/3 of that. And we've taken 1/3 of that and turned it into 1,000 lines of code. So we're replacing millions of lines with thousands of lines. And it's a big deal. Yep.
I'm assuming what you're saying is that capacity can be shaped at some level, but in our community, a lot of feedback I got from our local ISP groups that gaming is just swamping much of our bandwidth. So how does it get shaped in order it's being able to access the internet? And for a long time, games were platforms. Now it's built into the web browser.
Great question. Well, to be clear, I know how I would do it based on what I currently see, but I'll need to talk to Chase. We can partition the network and the bandwidth usage. So if you wanted to dedicate bandwidth to certain things like gaming and then throttle that and keep it lower and then make sure that there's allocated bandwidth for whatever activities that you want to be maintained working, even if gamers are getting ticked off because their latency sucks, right? And they just got shot because, they could pull the trigger faster, right? I get the pain. I got an 18-year-old son. 19 this week, actually, tomorrow. And so I think that we may be able to solve it in a way like that. But I would also say that one of the interesting things about capacity is when we're talking about a network that goes laterally, so it's not ever going to the big pipe, you're able to move at the speed of the devices, not the speed of your bandwidth. Does that make sense?
So, but does that mean it's understanding that the ping is local versus
yes,
remote? Okay.
absolutely. And I would say that in addition, so think about it this way: Wi-Fi 7. Anybody know how fast a Wi-Fi 7 router can transmit data? The one that we're looking at, the one that Netgear is asking us to replace or to do the Wi-Fi 6, we have the Wi-Fi 6 variant now, Wi-Fi 7's next. Okay, we have that variant already selected. It's 10 gigabits per second. 10 gigabits per second. There's the big brother of that version is twice the price, and it's 20 gigabits per second. Okay, if I start connecting devices across a village with 10 gigabit per second wireless speeds, and all you need is the information on the other side of the village that's at the library in a hard drive, well, guess what? You're not getting 100 megabits per second internet to that data. You're getting instantaneous connection to that data. So your local traffic, the things that you keep locally, you're going to access way faster than you could get from your ISP. And then the people who need the internet, like the gamers, keep going to the internet. And they have less traffic to deal with, so everybody's happy. Maybe. I don't know. That's what I'm thinking.
You know, being that we just had the subsea fiber issues twice in our region where it got cut, everything is shut down. Now everybody's panicked trying to get out there and get their information, communication. It would be amazing. I think this would be an amazing technology to solve the local problem of being able to access things locally still.
Yep.
While making priority the voice traffic that couldn't get out before. And
Right.
shut down all of our emergency phone lines and every connection in town.
Yeah. Now, I live in a rural area, and I hesitate to even say that in this room because East Texas rural is not the same thing as Alaska rural, and I get that. I get it. Okay, but I go to a cowboy church, you know, and I have my property with my connectivity issues so that I can share the pain. Mine are a lot less difficult to deal with than yours. But yes, this technology and this capability is absolutely intended to solve those problems. And one of the areas in my town, we have the biggest flea market in the United States that happens once a month. It's called First Mondays. And this little podunk town of like, you know, a couple thousand folks grows to like 100,000 people once a month. And when that happens, the internet's awful. And, you know, it's not just the internet's awful, okay? Like, human trafficking becomes a problem. When people know that you can't communicate and fire can't get called and all this kind of stuff, predators know you're going to have connectivity issues, and that's a hunting grounds. And I see these Amber Alerts and things that happen, and it breaks your heart, right? This kind of network goes into stuff like that, which is the commercial, industrial, indoor, outdoor Wi-Fi, right? This is what we have today. And now those first responders can have an entirely partitioned place for their services. The cameras that are doing AI facial recognition for people who are known threats, those can work when you have a network that allows you to partition bandwidth and keep it at the edge to do what it needs to do. Make sense? Yes, ma'am?
So the technology is trying to reduce the traffic that does not necessarily need to go to the main bandwidth, but it does not increase the actual bandwidth that you are looking
Correct.
to. Okay, thank you.
So think of it this way. Right now, if I try to call you, even though we're right here, okay, my phone has to go to the cloud to find your phone number and name and where you are in the world to send that message back to you. That's how it works. In our network, that message is technically capable to go straight to you. What has to happen is the applications that do those phone calls have to be built, and that's one of the reasons we've struggled, to be quite frank, as a company, up until this point when we have this contract with Breath of Life. We've had electricity in the walls and talking about the potential of the light bulb, and everybody's like, I don't know what you're talking about. Like, you got what in the walls, right? Because we're talking about an invisible firmware that lays at layer 2 that nobody ever thinks about. So we've been trying to replace that, and it's that application that has to know that, okay, phone numbers in this local area are stored in such a way that osmosis finds those, recognizes you're across the room, and moves that message directly to you. And that is the stuff that we're building. We have a lot of this already built. Like I said, we're going to be launching our SDK, our development kit, this month. We're going to have an application that's demonstrable by the end of the year. And as soon as we get our funding targets met, which we're working on, within 6 months of saying go, we will have the ability to have any application that currently runs on a server will be able to run on our networks with less than a day of configuration. Yes, ma'am. Yes, ma'am. Yes, ma'am. Yes, ma'am. She said, so we're basically trying to keep the messages that don't have to go to the internet at the edge. And I confirmed that and then gave a very long-winded explanation of why that was. Yes, sir.
Are you planning to roll out with other carriers like Ubiquity or other?
Yep, that's a great question. So our partners at Teltech are Lisa Hanlon, like I said, she is an equipment distributor, for example. And what we're essentially doing is talking about adding a value to other equipment manufacturers' stuff. So through partners like Lisa, who kind of knows everybody in the industry, we're hoping to get those equipment manufacturers to work with us to put that into their devices. Right now, we have a company called WaveSight that's out of England that provides a lot of different solutions. You'll hear about some of those, I'm sure, from some of the vendors here, because they do 5G cores, and they also do, and we can sell all of that stuff, by the way, if anybody wants to know more, talk to Lisa. She's selling all the hardware for us here. We also have their outdoor router that's very, very good. And then we have the Netgear indoor commercial industrial Wi-Fi solutions as well. So right now it's Netgear and WaveSight. We also have an old contract with the Bandtech we could revisit if we needed to, but we want to be in Airspan, Ubiquity, Cradlepoint, Tirana, everybody. Like I'm not trying to compete with folks. I'm trying to make them more successful. Because ultimately, you know, I really love the mantra, you know, it's amazing what you can accomplish if you don't care who gets the credit. I want the OEMs to get the credit. I don't need the credit. I can be on the label on the back. That's fine with me. But we need to solve this problem. Any other questions? Yes, ma'am?
So I was just wondering, like, from your pictures and stuff, if you're in that fastest path, can you go dark and be offline and then it would find another path? Like, say
Yes.
you're a school and you don't, for whatever reason, because you had a data breach, you need to just get off, or if
Yes.
you are the biggest one and it keeps going through you.
So we did a demo in England a year ago where we took something called Internet in a Box, which is a proprietary thing. I don't know much about it, but you know what it kind of reminded me of when I opened it? You guys remember those CD-ROMs with the encyclopedia on them? You had like 20 discs. You're like, oh, it's the middle of the M's, darn it. Got to change the disc out. And then it's 10 minutes later and it comes up. Okay, so it's like that, but better. Internet in a Box. And it's got, you know, terabytes of information on on like this little bitty, I don't know if it's like this Raspberry Pi size, a little bigger, or huge amounts of data that can be stored on these things. You plug that into any of the internet sources, just like it was a backhaul. It uses an Ethernet cable. You plug that in, and immediately everything in line of sight can access that hard drive. So your school scenario, for instance, that's all demonstratable capability, but like it's not productized yet. We can work on that. There's so many industries and features that we could build that we're trying to make sure we're getting the ones that are most valuable to you all first, which is why I'm soliciting feedback so often. But ultimately, you put that hard drive, could be a computer, it doesn't have to be a server, it doesn't need a server room with the air conditioning and everything that goes with that. It could be a computer that has osmosis on it, has the data you want all the students in your village to be able to access and see, and they can access that at the speed of the connections between their devices, and even if the internet is totally gone. Yep.
As people move to more commercially off-the-shelf applications for their services versus server-based applications, the result is they need to convince those application providers to put your SKD into their application so that it can run offline.
Yeah, well, that's our job, right? That's the thing that we're trying to do. So what I want to do is provide the OEMs with the value, like here, integrate this, and your stuff now has osmosis on it, and then we continuously push updates that allow new applications to run, because we're going to be building APIs for our SDK. We're going to continuously build new APIs. We can do things with positioning, for example, because of the way that our devices are constantly pinging the environment. We can do things with positioning that the Air Force wants, for example. So like the APIs have to then get created, which for those application developers to build what they want to build. So what we're doing is we're going to the, where we want to cover an entire geographic area, right? We want the entire village to be lit up. So we're looking for the equipment that matches the spectrums that are used for those kinds of distances. And we're setting that network up. And then the second thing we're doing is going over and working on the development, selling the development. And basically our pitch is, hey, you've never had access to these customers before. Now you do. And we're a really good deal right now for like the first year or two, but eventually we'll charge for API calls to use our network. Now, once we get to that server-based, like everything that's server-based can run on our network, that's first step. The next step is to convince AWS to just work with us to put osmosis into AWS and activate everything that's currently using AWS for an application. Essentially, we want to make sure that the server, once you build the network, decentralized storage is next. If you're technical, you kind of see what I'm saying, right? So that's what we're essentially, we have to lay the network down, put some applications on it, show the value, and then the big investment comes. That's when we get a lot more applications, decentralized storage capabilities. We start to end the mass use of server appliances, and those become used for enterprise applications only, or where somebody needs cloud backup for some reason.
Thank you.
Anything else? All right. Thank you very much for your time. I will be around.